Good afternoon, you all, and welcome to this training session named as Generator Excitation System. So, on today, on this particular session, you will be learning about the excitation system in generators in conventional thermal power station and hydro power station. So, generator excitation system will be discussed, and because of shortage of time, we will be discussing quite fast. So you can send me the query to this email ID. So you can send your query to this email ID later on, and you can send your query through WhatsApp also to this number. So already we have learned so many things regarding a thermal power station, because the name of the course is Thermal Power Generation Technology. So you have learned about boiler, you have learned about turbine and some other auxiliaries and accessories in thermal power station. So ultimate aim is to generate electricity through generator. So generator is rotated by turbine, and how is electricity generated by rotating the generator through turbine? That class already it was done. So you came to know how power is generated through a generator. Now, in this class, you will learn exactly how power is generated. That means turbine is rotating the generator. Then how exactly power is generated from mechanical into electrical. So it is just some slides I will be repeating. Say for a generator, the input is from the turbine, and the input is in the form of mechanical energy. So mechanical energy is the input for the turbine generator from the turbine, and to the other side from the generator we are getting electricity as output. And you know that electrical power, it is not a simple power. Rather, we are writing electrical power as your S equal to P plus JQ. P is the active or real power, and Q is the reactive power. So P plus JQ, both these two togetherly are constituting the total electrical power, that is S equal to apparent power or total electrical power. So P is the real power, that is in megawatt, kilowatt. Q is the reactive power, that is your var, kvar, mvar, and S is the total power, that is kVA, MVA. So how electricity generated? Simply mechanical energy is the input and output is the electricity. So how it is getting converted? Inside the generator it is getting converted. So of course there is some medium inside the generator which is converting this mechanical into electrical, and the medium, already most of you know that the medium is the magnetic field. And how the magnetic field is created? By providing DC power as the input to the magnetic field structure, so that magnetic field is generated. So inside the magnetic field, when turbine is rotating, then there is flux cutting action, and due to that flux cutting action, the power is generated. So magnetic field creation is necessary. So in this class, you will be learning about how that magnetic field is created inside the generator. That means how the magnetic field structure is excited from the DC power to create the magnetic field. So DC power is available from some DC source, and that DC source is known as the exciter or excitation system. So that is also one input to the generator. So for the generator, Two inputs are there, mechanical energy from turbine and DC power from the exciter or excitation system, and ultimate output is electrical power. And no machine is 100% efficient, so there will be losses. So this is the input output diagram for any generator, theoretical diagram, and practical diagram you can see here. You can see here, this is the turbine, this is the turbine. So this is the turbine housing, this is turbine, so that is the mechanical input, and this is the exciter, that means the system to provide the DC power to the generator, and this is the generator. So this is the picture of 115 megawatt power station of DVC Mejia in West Bengal. And similarly, another picture you can see, that is your this one. So here also you can see that this is the turbine housing, this is the turbine, this is the turbine housing, this is the turbine, this is the exciter from which DC power is obtained, and this is the finally generator. So this is the picture of one 500 megawatt thermal power station and of NTPC Chandrapur. And this is again another picture to show you the practical layout or practical position of turbine, generator, exciter, whatever we studied or just have seen theoretical, that turbine input, then exciter input, then output. So that here again you can see that this is the turbine housing, turbine, this is generator, this is exciter. So input output diagram you can see, and from the bottom of the generator, from the bottom side, the power output is taken, three-phase power output is taken, and the floor that you have seen, the floor that you have seen, that is the floor at the level of fourth floor or fifth floor of a common building. So because at the bottom places there are the auxiliaries are there, BAP, CEP, then your economizer, all the accessories or auxiliaries are available below the floor, whatever is seen in this picture. So that is the input output diagram. So that is just a division. So our aim here is to discuss about this exciter. About this exciter we will be discussing. Now you know that for any generator or synchronous machine, there are two parts mainly. One is the stator. Stator means stationary part, and in case of synchronous machine, the stationary part means armature, and the rotor, that means rotating part. And you have studied most probably during construction of generator that the rotor is of two types, silent pole type and cylindrical rotor pole type. So whether it is a generator or motor, in both the cases, the rotor may be silent pole type or cylindrical rotor pole type. That depends on the application. That means in which type of power station the generator is going to be used. That is important. If it is a hydropower station, obviously it will be a silent pole type generator, and if it is a thermal power station, then it is a cylindrical rotor generator. So why silent pole in hydro, why cylindrical rotor in thermal? All these are actually should have been discussed in earlier classes. That is not in the scope of present class. That is excitation system. Now here, just before going to the exact excitation system, you should know the structure of cylindrical rotor and salient pole. Already most of you have seen in the generator construction that class. Still, just as a recapitulation, I have kept some slides. Now let us go through those slides. So these are the conductors of the cylindrical rotor structure. These are the conductors, and this is the retaining ring at one end. This is again the retaining ring at the other end, and these two rings are required for you covering the end winding. These two rings are required for covering the end winding, and the active length of the conductor inside the stator is from here to here. That is the active length of the conductor in the rotor or field structure, which is actually creating the effective magnetic field for cross cutting. And these are the two slip rings for providing the DC power. One slip ring for positive end, other is for the negative end. So these two slip rings are there, and on the slip rings, brushes will be slipping, and this total structure, this total cylindrical structure will be rotating. It is actually on the shaft, mounted on the shaft, and turbine is directly connected. Turbine shaft is directly connected here. That's why it is written coupling. That means here the turbine shaft is connected, and here in this side turbine is there. So turbine is rotating. So this total structure, that means total cylindrical rotor will rotate. So that is the cylindrical rotor structure. Theoretical diagram, practically you can see here. Here you see this is the retaining ring, and from here you can see these are the effective conductors, and here this is actually fan, axial fan for continuous cooling. So you have seen the cylindrical structure, and here you see how in the cylindrical rotor structure power is generated. In the cylindrical rotor structure, here you see in the cylindrical rotor structure, 2/3 of the total surface is given the winding, and 1/3 is vacant. Just like this is a vacant surface, blank surface, diametrically opposite. Also, there is a blank or vacant surface. So here, these are the conductors which will be producing the necessary magnetic field, and these two are the slip rings, and over the slip ring, one brush and other brush. This is one brush, this is another brush. So this is the theoretical diagram, and here you see if say this is positive and this is negative end. So from positive end, current is entering and current will circulate like this. Current will circulate through the conductor, and ultimately it will come out through this brush. Okay. Now how the north pole and south pole are created in the cylindrical rotor structure, that you should know, you should understand. Now in the for any conductor you know that whenever current flows through a conductor, DC current flows through a conductor, a magnetic field is produced. And for that magnetic field, you say for any for any conductor, say it is the conductor and current is flowing in this direction. If it is so, then you know that one magnetic field is created. One magnetic field will be created across it like this. One magnetic field is created. That means if this is a conductor, current is flowing, then magnetic field will be produced, will be created in this direction. Just you notice the thumb rule. Maybe just thumb rule. If this is the current direction, then if this is the current direction, then this will be the magnetic field. Okay. If this is the current direction, this will be the magnetic field. Similarly, here you see here here just see the current will be going like this. So from here, current is dot means current is coming out. Cross means current is entering into. So from this end, current is coming out. So that is this end. Now here, current is coming out, then entering here because dot and cross. Current is coming out, entering here. Current is coming out, entering here. In that way, it is there. So ultimately, what is happening here? Magnetic field will be created in this direction. Each and individual, every conductor will produce magnetic field like this, and ultimately, this will be the resultant magnetic field direction. Similarly, the cross conductor will be each and every conductor will be producing magnetic field like this, and as a resultant, as a whole, this will be the total magnetic field by the conductors. Now you consider one magnet or any magnet. Now lines of forces are coming out from North Pole entering into South Pole, coming out from North Pole entering into the South Pole. The similar thing is happening here. These line of forces are coming out from this end, and entering here, entering here. So ultimately, North Pole is created here and South Pole is created here. Okay. So in this way, North Pole and South Poles are created in cylindrical rotor structure. Now you consider a four-pole structure. That is a two-pole. This is a two-pole structure. And now consider a four-pole structure. Here you can see that the number of conductor per pole is reduced. Number of conductor per pole here is less. North and south. So number of conductors per pole is less. So ultimately, what is happening? If you are going to construct a four-pole structure, since number of conductor per pole is less, so you have to make more current to flow through the field structure. So which will create the heating of the rotor structure. Now you just imagine for 6 pole, 8 pole, 10 pole like that, then you can understand that 4 pole is already quite difficult. So 6 pole, 8 pole, this type of constructions is beyond the possibilities. So from construction point of view, cylindrical rotor structure demands for minimum number of pole. If it is 2, then it is very good. If it is 4, then somehow can be managed, but beyond 4 number of pole is not at all possible for cylindrical rotor structure. Clear? So in this way, the fields, that means North Pole and South Poles are produced in the cylindrical rotor structure. So what is required? The requirement is that you have to provide DC power here as an input, and from where we are getting the DC power? That is the excitation system. So that still we have not entered into exact topic. Just recapitulation is being done. So this is the cylindrical rotor construction. I think we have understood how the field poles are produced in cylindrical rotor structure. Now coming to salient pole, it is very easy. Just as a plain solenoid, in plain solenoid, what is done? In plain solenoid, just you keep on magnetic material as the axial material, or at the axial position you just place on magnetic material and keep the current flow. Keep the current flow. Just you see this structure. Here current is entering from this end and ultimately it is leaving out from this end. So what is there? This is nothing but a nothing but a electromagnet. Similarly, in case of salient pole, salient means something that is projected out from the main surface. So this is the main shaft. From the main shaft, one pole is projected. Again, second pole is projected. So two poles are projected. In this way, many number of poles will be projected out. Now, here you see from these two slip ring and process, the DC is given as the input, and ultimately south pole and north poles are created, and how the south pole and north poles are created, you from this structure you can easily understand how south pole and north poles are created. You can easily understand. Now you see for two pole structure, the air gap is here very less, air gap is less, and here air gap is more. So because of this different air gap throughout the air gap periphery, what is happening? The magnetic field flux distribution is not uniform. Where the magnetic field is very strong, where the air gap is small, and magnetic field becomes weaker where the air gap length is more. So ultimately, with this type of structure, just see two pole construction with salient pole structure. If we go for this, then what will happen? The voltage produced or the power produced by this way will be of fluctuating type, because the magnetic field distribution will not be uniform. So to compensate that, what can we do? We can keep again one north pole south pole here, so that this gap and this gap is reduced. Then what will happen? Then at this moment position, again one gap will be created, again one gap, again one gap, again one gap will be created. So to compensate those gaps, again north pole south pole, north pole south pole, north pole south pole, in this way one pole pair to be placed. So ultimately what will happen? Many number of poles you have to place so that the air gap becomes uniform. You just see these pictures. Here it is a 6 pole structure. This is the main shaft spider. From that one pole is projected out. Second, third, fourth, fifth, sixth. In that way, 6 poles may be projected out. This is a 6 pole structure. This is some 8 pole structure. This is some 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 pole structure. So in that way you see, and here are so many number of poles. So these number of poles are many more in case of salient pole structure, because to make the air gap uniform. That is the main reason. Now you consider 120 F by P equal to N. That one. Now you see 120 F by P equal to N. If you see this structure, see this equation, then just see NP or your NP is your 120 F, and that is a constant value. Why constant? Because F is the frequency, say 50 Hz. So 120 into 50, then 600, 6000. So that is a constant. In European country, 120 into 60, that is 7200. That is also a constant. So NP is ultimately constant. So what is N into P? Constant. So we can write N proportional to 1 by P or P proportional to 1 by N. So now you can imagine, you can understand why salient pole structure is used in hydropower station. In salient pole structure, the number of pole is more. By construction, you have just now you have learned that the number of pole is very high in case of salient pole structure. So speed will automatically be very less. This speed, this speed will be less. And in hydropower station, you know that Francis turbine, Kaplan turbine, Wilton wheel, all these are slow rotating turbine. So therefore, the salient pole structure is very much suitable for hydropower station. Similarly, in case of cylindrical rotor structure, just now we have discussed that in case of cylindrical rotor structure, 2 pole is very suitable. 4 pole somehow can be managed, but 6, 8, all these are not possible. So cylindrical rotor structure demands for minimum number of pole, and if the number of pole is less, then speed will be high. And you know that thermal, in case of thermal power station, that is steam turbine or gas turbine, these are high speed turbine. So these are very much suitable with the cylindrical rotor structure. So cylindrical rotor structure will be used in thermal power station and salient pole will be in hydropower station. So all these are actually of recapitulating type, just to understand how the magnetic field is affecting the creation, power creation. Okay. Now here you see, I have kept some pictures for easy understanding by you. That here some number of poles. So here some number of poles. You can see North Pole, South Pole, North Pole, South Pole, North Pole, South Pole. In that way, here also again North Pole, South Pole, North Pole, South Pole, North Pole, South Pole. In that way, the poles are there. Here also, if this is a North Pole structure, this will be a South Pole structure. This will be North Pole. In that way, the pole structures are there in salient pole machines. And this is a rough sketch for the salient pole rotor generator in hydropower station, turbine, main shaft, and generator. And total structure from here to here, total structure. To understand the size of the structure, you can just see the size of a person here. All these are actually exactly not for the excitation system class. Directly I would have started that one, but still I have kept all these for just recapitulation and easy understanding, so that directly starting the excitation system will not make any difficulty for you. Now we will exactly see the excitation system. Definition and need already that is told to you that definition means what is excitation system. So excitation system is nothing but the DC source, one system, one electrical system we have to make from where we can get the DC power. That is the excitation system. And why it is needed? Already you already have seen that in the rotor field structure we have to provide the DC power so that the North Pole and South Poles are produced. So that is the major necessity of excitation system for the generator. And secondly, by the excitation control, that means by controlling the magnetic field structure strength, we can control the reactive power generation from the generator, and that is very important and essential matter for the power system stability. So if you are able to control the reactive power, then you will be able to control the stability of the electrical power system. And here in the excitation system, by controlling the magnetic field strength, you can control the reactive power. So all this controlling actually is beyond the scope of this class. That is a separate issue. Now types of excitation system. Generally, four types of excitation systems are there, and all the four types we will study. So, just a brief description. Already, this picture and detailed description it was done. Here also the detailed description already done for cylindrical and cylindrical rotor. And these literatures you can later on go through, just explanation and some information. You can go through. If anything, then you can ask me through WhatsApp or email without any hesitation. You can ask, no problem. Uh, One thing only is that here you see formal practice of excitation bus fed. Formal practice of excitation bus fed by a number of exciters operating in parallel, supplying power to the fields of all the alternators in the station is now obsolete. That means in earlier days, what was there? There was a separate DC point. DC point means DC power point was separately available by running different DC generators in parallel. That means in the power station, that is the main power station to produce the power. There was a small power station separately by DC generators. So all those DC generators were running and they were parallelly making one DC power point from where the DC power was being given to all the generators one by one. So that concept, that means separately running the DC generator and therefore making one DC bus bar separately available, that concept is now obsolete. That means nowadays it is not at all available anywhere. And present scheme is to have the unit exciter scheme. Unit exciter means most probably you by this time came to know that what is the meaning of unit. When you visit some power station, then you will see that in the power station, the people are calling unit 1, unit 2, or unit 3, or there are 3 units in the power station, or there are 2 units in the power station. Unit means turbine generator set. Okay. So turbine generator set, that is called one unit. So if they say that 3 units in the power station, that means 3 generators are there in the power station. So unit exciter means the unit, that means the turbine generator set will itself have a separate DC source inbuilt type inside the turbine generator floor. That means separately or dedicatedly it will be available with the generator. As initially on today's class, initially I showed you some photos for 210 megawatt DVC power plant, 500 megawatt NTPC power plant, or 500 megawatt DVC power plant. So there it was shown to you the turbine structure and placement, excitation system structure and placement, and generator structure and placement. That means turbine generator exciter set that was shown to you. So that separate exciter for individual generator, that is known as unit exciter scheme, and that is the most common and most acceptable nowadays. And by unit exciter scheme, the generator is independent. That means it is not depending on any external DC source from where it has to get DC power. So it need not to depend on any external source. Inbuiltly, it is having its own exciter from where it will get the DC power. And these are the purpose or functions. Already I told you that the main function is to create the magnetic field inside the magnetic field structure. Second function, by controlling the magnetic field strength, we can control the reactive power. Some other functions are also enlisted here. I will request you to go through all these functions. If any point is there which you cannot understand, later on you can ask me through WhatsApp or email. These are simply the informative type. Main functions are the two, creating the magnetic field and controlling the reactive power. This slide is very important and helpful because so many informations are there. in this slide, and you see what are there rating of exciter. In case of 800 megawatt generator, the terminal voltage is 23.5 kV and the armature current is 23,586 ampere per phase. Then in case of 660 megawatt generator, the terminal voltage is 22 kV. Terminal voltage means armature voltage, the generated voltage, and the current is 20,377 ampere. And in case of 500 megawatt, 210 megawatt, 110 megawatt, you can see the terminal voltage and the armature current. Now, for 800 megawatt generator, to create this much of voltage and this much of current, what is the voltage? What is the requirement in the field structure? In the field structure, the voltage is 506 volt and the current is 4950 ampere. In case of 660 ampere, 660 megawatt generator, to create this much of voltage and this much of current, the voltage in the exciter is 491 volt, current is 469 ampere. Similarly, for 500 megawatt generator, this is the voltage, this is the current. So you can see the exciter side, the voltage is never beyond 500 volt. That means voltage is less, but current is very high. With the 506 volt only, the current requirement is 4950 ampere, 4669 ampere, 4040 ampere. That means voltage is very less, current is very high in the excitation or exciter scheme. So in the excitation structure, that means in the rotor field structure, why the current is more, voltage is less? Voltage is, you know that by making flow more current, the magnetic field can be made more stronger. Okay, the magnetic field will be strong if we make more flow of current. So magnetic field, to create the required magnetic field, we emphasize on the current rather voltage. That's why voltage is less and current is more in the field structure. Now you can see some other factors also. Normal exciter rating is 0.3 to 0.6% of generator rating. What is the meaning? The meaning is that it is a 800 megawatt generator. Now in the field structure, 506 volt, and this is the ampere or current which is required to create the 800 megawatt. So you just multiply these two, 506 and 4950. Multiply these two, you will get some watt. Divided by 800 megawatt, you will get this percentage, 0.31308. Similarly, 491 volt into this 4669 ampere, you will get the wattage rating of the exciter. Divided by 660 megawatt, you will get 0.3473%. That means the normal exciter rating is 0.3 to 0.6%. That is a standard practice. That means while designing the exciter scheme, the exciter scheme is designed in such a way that the power rating is falling between 0.3 to 0.6%. That is the standard rating. Or another measurement is that 10 to 15 ampere per megawatt. For making 800 megawatt, current is 4950. So just divide this 800 by 800 megawatt. 4950 divided by 800. Just divide 4669 by 660. 4040 by 500. So you will get a value between 10 to 15. That means it is also a measure that 10 to 15 ampere current should flow in rotor field structure for per megawatt of power generation. That is also one rating. And field forcing condition is 1 to 1.5% of generator rating. And most of the modern exciters are capable of putting out. So what is the field forcing condition? By chance the generator is overloaded by some chance, by say some load is removed all of a sudden, or somewhere some fault is there, or some generator is facing some fault and it is switched off. In that way, load has come to other generator. In that way, a generator may be loaded. All of a sudden, it may be loaded beyond the full load capacity because of fault or because of some other generator is switched off by some other fault. That means ultimately because of fault. So that time the generator should be instantly capable to supply more than the rated power. Otherwise the generator will be heated up and it will be burned. So it is there that the armature or field structure should be able to provide some more amount of power during fault condition. But you know that whenever fault is created, as soon as fault is created, relay is sensing the fault and disconnecting the generator from the supply. But within that fraction of second, you know that in electrical engineering, 0.001 second is also considered as a very big time. But that means 1 by 100 seconds or 1 by 1000 seconds, that is also considered in electrical engineering as a big time. So fraction of second is also important. So within that fraction of second, the generator should be able to supply more amount of current. So how much more amount of current or power it will be able to supply? Generally 1.5%, that means 150%. 150%, that means more than the 50% more than the rated value it has to supply. Sometimes with the modern generator, making them more harder or rugged, this is also followed that 300 to 500% they should be capable of supplying so that the generator will never get damaged. So here you will get in this slide many information about the rating of the exciter, and all these data are collected by visiting the different power stations practically, not taken from internet or anywhere else. So that's why I am repeatedly telling that this slide is very important, because all the data shown here are collected by physically visiting the power station, not from anywhere else. Now types of excitation system. You see, I have kept 3, 2, 1, 0. What is the meaning of 3, 2, 1, 0? I will tell you later. First, you see the excitation system. Initially, it was the classical DC excitation system. Then came the high frequency excitation system. Then static. So, what is the meaning? Initially, in the classical DC excitation system, slip ring and brushes were at 3 places. Then in high frequency excitation system, it is an improved version, and slip ring and brushes were at 2 places. And in static excitation system, it is further improved version of excitation system and at only one place. So that's why I have written 3, 2, 1. Okay, 3, 2, 1, 0. That means the placement of slip ring and brush in the system. So in the classical DC excitation system, slip ring and brush at 3 locations. In the high frequency excitation system, slip ring and brush are at 2 locations. In the static excitation system, slip ring and brush are at 1 location. And finally, the most modern is the other class, right? And finally, the brushless excitation system, where number of slip ring and brushes is 0. That means slip ring and brushes are absent. So we will discuss all these in the next session. That means just shortly we will be getting disconnected. I request you to be online and again log in, and then we will discuss one by one.